Once upon a time, there was a young chemistry student named Maddie that didn't know the atomic spectrum. As she studied and studied, she didn't understand any of the terms. That left her very confused. ...
The atomic spectrum is so much harder to learn than it looks. I've been looking at this information for days and nights and days, and I still can't get it stuck in my brain. I wish there was an easier way to learn it.
So I hear you're confused with the atomic spectrum.
Yeah, I am. There's just no way to get this information down.
Well, lucky for you, I'm a chemistry whiz. I'm pro at this atomic spectrum nonsense. I can help you.
Gee, thanks, Emily. Where should we start?
Let's start with the Aufbau principle. This is used to determine the electron configuration of atom, a molecule, or an ion. Now, isn't that simple?
No way, Jose. I mean, I know what electron configurations are, but they're just really confusing.
Let's practice with electron configurations. We can do this by playing hide and seek and counting to potassium.
Okay, I'll count first. 1s1, 1s2.
What Maddie doesn't know is that I've been planning this all along. You see, I'm going to hide in different places, and at each place, Maddie will find me, and there'll be a new thing to learn.
5, 2, 6, 3s1, 3s2, 3p1.
Atomic spectrum, atomic spectrum, Now here we go. First we want to cover all important info. Let's start with simple like exclusion principle. This is that electrons spin oppositely. If you want to understand them, listen carefully. Moving to the next part, it is Hahne's rule. It is kind of like a bus full of people. If they're open, teachers sit there first. Then if you have to, you gotta share the space. Now we wanna talk about the electron cloud, the area around an atomic nucleus, similar to if you were in a hamster ball, and the world around you would be the electron cloud. Photons are little, similar to angels. They have zero mass and no charge as well. Fortunate for them, they have a long lifetime, but can be destroyed if they absorb radiation. Frequency, amplitude, and wavelength, all of them have to do with waves. Frequency is the number of times a wave passes a fixed point, while amplitude has to do with how it lasts. Wavelength seems obvious, cause it's the distance between two waves. Atomic spectrum, atomic spectrum, atomic spectrum, atomic spectrum, atomic spectrum, atomic spectrum. Now here we go. Let's say we're spinning in a whirling. Think about it. That will then demonstrate electron spin. You're the electron and your leg is the axis, and the fact that you are spinning is the property of this. Unlike a ball, I don't have a fixed radius. Find the radius, you have to measure the distance between the area of touching atoms. Finally, you have to have the distance. Orbits and orbitals can be mistaken for the same thing. You see an orbit have a definite half, but an orbital is a radius space. According to Heisenberg, you can know the position of an electron and where it'll be at the same time. Atomic spectrum, atomic spectrum, atomic spectrum, atomic spectrum, atomic spectrum, atomic spectrum. Learn it with me now, last we want to talk about the ionization energy. It's energy required to move an electron from an atom in its gaseous state. Kind of like if you were to steal something from someone. A similar thing to this is the energy you're using to take the item. Now that we have covered all all these germs. I hope that you understand more. See, atomic is truly difficult. Just have to know where to start.
My favorite food is grass because my name is Jerry the giraffe. Hee haw. Wait, that's the donkey noise. Never mind.
Barbara Streisand.